I realize when I get in teaching mode, I don't really look at what you guys look like, so I'm doing it now. So I'm checking you out. Oh, you don't have to stop talking. It's all right. Oh, I guess it is time. Never mind. Stop talking. Let me close my door. Okay. Hopefully they'll be here soon. So, welcome back. Anybody new that hasn't told me? Couple. Welcome. Were you able to see my syllabus?
No, sir.
So, did you look on Canvas yet about this class?
I haven't. I just registered yesterday.
Ah, okay. You familiar with Canvas? Head nod or something? Okay. I'm not using it, but I put a link there where we will be going to Webassign, and I'm going to show that again in a moment. And there's a link to my syllabus there, as well as in Webassign. And that's what we mostly went over first class. It has all the logistics, things you need to know, schedules, calendars, they're posted in Webassign, where you can go to get things, blah, blah, blah. Read it and let me know if you have questions. You can email me. That's there as well. Any questions you have now that you've had time to look something over? Is it possible to get the textbook on Webassign? Yeah. No one in my class has opted for the ebook yet, so I'm unfamiliar with it. But I know either way, you're going to have to pay for it.
Yeah, I have another class that also uses Webassign, so I might as well just get the ebook for that.
Get the ebook on Webassign. So have you actually followed the steps?
Yeah.
And it didn't show up?
It didn't show. It shows the book, but there is no. I cannot find a link to buy it.
Okay. I saw the link I saw wasn't through Webassign, it was through the bookstore, where it showed you what the normal book would be, yeah, and an ebook, and you could purchase it there. I will look then where they told me they were stashing it. I remember seeing it though through the bookstore once within the last couple of weeks. Okay. Okay. Welcome. Other questions? Concerns? Groovy. I encourage you again to read about the superhero paper so you're aware of it. It won't be due till later in the semester, but I want you guys to have all had a chance to read it before we discuss it in grimy detail. But
so, my brother went to college and he has a clicker. If I use his, will it work for this class?
well, your brother's clicker worked for this class.
I registered it.
Is it from Turning Point? My guess is no, but we can try it, and we can try it today, because maybe you'll get lucky. I will start accumulating points next Monday. I prepared a few questions today, so because I still want to, sounds bad, probe you, and you can see those of you that have gotten yours since Monday if they're working. But I won't start counting participation points with them until next week. I figured that was fair. Sound good? Okay. I've had a few questions about ResponseWare and Webassign. But I've answered those. Let me show you something then. All right, here's the University of Utah's Webassign login page. Is anybody not bothered going here yet, other than the new people? Now that's good, so at least looks familiar. The button down here is the login. Yes, I know you all see it. I'm just making sure you all see it. because I always hated people that disliked people. My mom taught me not to use the word hate. Yeah, go in and out. When they do something, oh yeah, go here, and then they do it, and it's gone, and then you didn't have a chance to see it because you were finishing your sentence you were writing. Anyway. You use your university code and password. Oh, bummer. That's what I get for logging in multiple times today. I wanted it to show the screen. Maybe if I do the student view. There it is. Most of you saw this or still see this. Brian, this was your email question. Down here it says, I would like to purchase access online. If you hit continue, it'll allow you to purchase it right there. You get 14 days from the beginning of class to buy this access. After that, you'll be denied access. You can't get in and see and do anything. Until then, you can choose, see we have 11 days remaining. So I'll continue my trial period, and you can go with continue. And so at least you're able to see things until you purchase it. But after that 11 days are up, you have to buy it or you're going to lose points.
Can we purchase it at the bookstore?
This is right here. You click and buy it, purchase access to Webassign online directly. It's kind of like Canvas, those that are familiar with it, but its specialty is so you can do your homework online. But it also allows me to post announcements in the syllabus and the calendar and whatnot. So I did post something since last class. You want the good news or the bad news first? Bad news first. Another homework assignment. It's posted. I warned you. It's right here in the upper left. Your current assignments. You have the Get to Know You assignment, which if you haven't been into it yet, it's pretty easy. And that's due tomorrow. And then I posted homework 1, which will cover chapters 1 and 2 that we will get through this week. And that will be due Sunday at 11:59 p.m. So you have the whole weekend. Monday we'll start chapter 3. And we'll go through that chapter 3 and 4. And homework 2, which I have not posted yet, will be due the following Sunday. That's in the calendar, which if you forgot, you can view right up here. Or if you prefer to print it out, like me, I made a PDF of it down here. New people, that's where you can get your syllabus and paper instructions and whatnot. Good news. Oh, yeah, good news, then I'll go do it. I posted this announcement about lecture video. If you haven't noticed, I'm wearing a mic, and our friends at new name, Teaching and Learning Technologies, formerly Instructional Media Services, we pay for them to record the lectures for your benefit. And they've already done the first one, and I've posted it online. And that gives you the link, tells you about it, so that you can, for these reasons maybe, view it. I do want to say, since I have you as a captive audience, my intent, and I strongly discourage it, of course, that you not skip class. Because, oh, I can just view this anytime I want now. You will miss out. You will miss the interaction. You can't talk to me directly. You won't see the demonstrations live. And you'll miss out on participation points. So, but I do want to give it to you because some people want to see these demonstrations again. Or you want, how did Adam say that again? I just need to hear that again. That doesn't make sense to me. It's there for you. Brian, we've contacted Disability Center, and they're working on making it closed captioned and said they will post it when they're done. Sweet. It's done.
I forgot to ask earlier about someone volunteering to take notes. I have some special paper or I have a paper that you take to CDS and you can actually get paid to take notes for the semester.
So if you didn't notice, Brian is deaf, and he could use someone to help him take notes for himself. You can get paid for this. It's basically, if you're taking notes for yourself anyway, you could make copies and give them to him, share them with him, and get paid for this, I guess. We're looking for volunteers first. Anyone interested? We have 1, possibly 2, possibly 3. Great. Should I have them talk to you directly?
Yeah, come up after class. Yeah, I saw a couple of somebody up here.
I know Rachel. Red shirt and black jacket. Thank you. Yeah, talk to him, fight it out. Or maybe you could, well, you discuss it.
Come up and talk to me after and we'll figure it out.
Figure it out afterwards. Thank you very much. I'm sure if he doesn't like what you're doing, he'll fire you. I don't know. I'm going to click in homework assignment 1. And I want you to be aware of a few things that people often don't realize until after they wish they had. It shows you the number of questions and how many points they are. It says when it's due, total score, name of the assignment, the info that a lot of people don't realize. But what I like is like on this first question, see this plus sign right here? If you open it up, there's a dash there out of 1. So you have no points out of 1 right now because you haven't answered it and you haven't submitted it. But it shows also how many parts there are to the question, which will be obvious. But remember that multiple submissions option? This one is one where I gave it to you. There's 5 options, so I'm going to give you, I gave you 4 chances to answer it. If you answer the first time and hit submit and you're wrong, you can submit again for half credit. If you're still wrong, you can submit a third time for half of that credit. So at least you get multiple chances and can still get credit other than an outright 0. Also, you'll know mostly what the correct answer is right then. Does that make sense? But if you're curious how many chances you get or how many points it is or have I submitted it yet, it should tell you. See, you can submit just this answer to this question, or you can just save your progress. Whee! Or down here at the bottom, you can submit the whole assignment at once. Your choice. Want you to be aware of it. Questions? Yeah? Nope. Not timed. You can stay logged in. You can print it, work on it later, come back, save your work, do it later, come back, then submit. And you can turn it in any time up to the due date. Okay. Back to chapter 1 about science. We got through one whole section. Mathematics. It's the language of science. You're right. And it really is. How many have heard of the scientific method? Yes. How many have ever done a science fair project before? Did they force you to follow the scientific method? And they made you do it all in glorious detail? What I find interesting as a scientist, and another reason I like Paul Hewitt, he agrees with me, or I agree with him, however you want to look at it. There are lots of versions of the scientific method. They're all similar. They got common points. But if somebody says, it has to be like this, not so. And in real life, we follow a method, but sometimes it's a lot more trial and error than you think. But there is logic to it. he says that there's no cookbook description, and I summed up his steps. You recognize a question. You know, and that's easy. It's like, hey, remember I said, how's that work? Why does it do that? What the heck is that? Where's it coming from? You're curious, and you want to know why or how something's working. So you recognize a question. You got to have something somewhere to start, and that's the hardest part for kids doing science fair projects. What to do? My daughter, she couldn't come up with something. She wanted to do a science fair project. She never decided. Now it's too late. She's only half heartbroken. Who's heard of hypothesis? How would you define it? I heard something. What? An educated guess. And that's my favorite definition. Sums it up. And I'm going to ask you guys a lot to try to answer my questions. I expect you to make an educated guess. Think about those terms. You're going to guess, which means you don't probably already know the answer. That's okay. That's why we're here. But it's educated. It's based on what you do know and what we've been discussing. So you can extrapolate. It's better for you to commit to something, then go forward and find out the answer, and then revisit what you thought. If you don't commit, you know, psychologists have found that you don't learn as much. And frankly, if you guess right, and what you learn is right, you haven't learned anything. So in reality, you know, not knowing what it is and getting it wrong and then learning what it is, you've actually, you know, gained and gone forward. So don't feel bad about that. Scientists probably make more mistakes than most people. It's if they give up that we never get anywhere. So you recognize a question, you make an educated guess, a hypothesis, and you think it's going to be something. You're predicting the consequences. Some people like to say it that way. Okay, so if I do this, I think this is going to happen, and why? Then, of course, you go and perform it. You have to do some test. And that's critical in science. That's one of the key things Hewitt mentions. Science is science pretty much because you can test it. But more specifically, you can test that maybe it's wrong. Just being able to test that something's correct doesn't fall into a hypothesis. You have to be able to prove it wrong. And so some people that don't make good scientists are because, ironically, they're too egotistical. And I've met a lot of egotistical scientists. So it's kind of a counter in terms because they have to admit when they're wrong or nobody will ever trust them in any of their results. And they have to be willing to make public their research up for scrutiny. And it's got to be able to be tested wrong. If not, other scientists refuse to call it science. I have an example. And I don't mean for this to, if I offend anybody, that is not my intent, but intelligent design is a good example. I'm actually very religious, and another reason I love Hewitt, if you read this chapter, Science, Art, and Religion is the last section. And you can seek truth and find truth in more than one way. Science is one way. And with intelligent design, a lot of those proponents of it want it, they get angry with science. And the bottom line is, scientists have an issue with it because it can't be proven wrong. They're not supposed to. Be calling it wrong, it's just you can't test for it. So don't call it science. Don't ask us to put it in the science curriculum. You can teach it here. Don't make us teach it. That's usually been the biggest arguments in all these issues if you've ever followed any of the stuff on that. Does that make sense? It's very important with science that you have to be able to prove it wrong. Doesn't mean you can't find truth there. Just don't call it science. Well then, you test it, you get a result, you analyze and draw some conclusions. And good scientists then learn something about it and usually revise their experiment. Because they go, oh, I've learned this now. Well, I think my hypothesis now will be something. And they start over. Usually go through it many times. But that's the gist of scientific method. And frankly, whether you realize it or not, will probably be what you're doing when you're trying to figure out some of these problems. I present you the problem, give you possible hypotheses, multiple choice questions, and then based on what you know, you got to research it and figure it out. I personally seriously hope that you will be motivated enough, that's one of my goals, to go home and try some of this stuff yourself. And just pay attention. Hey, I am doing the scientific method naturally. It kind of comes naturally. If you want to figure something out, those are the steps. And let me know. Share them with the class if you learn stuff. Put them on the discussion groups. We can all gain from this. I sort of haven't figured out how to do it, but if you guys find cool stuff that you learn about or come across in the way of science, and specifically physics, I'd like you to share it. We can take some time in class, discuss it a little bit. Or if you got questions on physics that I'm not covering, I am happy to try to help you understand it. So there's some terminology in here I want you to know, and there's a glossary. Fact is one, because they're often misinterpreted in science because they're used a little different in the normal world. How would you guys define a fact? Something that's definite, can't be proven wrong. It's eternal. It's just ultimate truth, so to speak. Yeah. Okay. Anybody want to add to that?
I'd say the closest or the best answer we have so far.
The best answer we have so far. Brian.
Something that's already been proven.
Something that's already been proven. Result. Good. Any more? Somebody wants to contribute? Something that's been tested many times. You guys are definitely on the right track. We do have, some of the responses implied that facts could change. But the first one, if I'm assuming you're right, the assumption was that it doesn't change. That's the way it is. Which one? Those contradict. It can't be both. What do you think? Take sides. Who thinks facts can change? Be brave. Who thinks they can't? Who doesn't care? Okay, because everybody didn't vote. Well, in science, facts can change. We don't treat them lightly, and we don't call them facts unless we think they've been tested and they're the best we have thus far. Let's see, what would he call them? A close agreement by competent observers, I like that term, competent, of a series of observations of the same phenomena. You know how when they make definitions they got to use big words. A close agreement by competent observers of a series of observations of the same phenomena. So they notice things, and it seems to describe our world, and so that seems to be the way it is. It seems to be eternal truth at that time. But you can think of examples. The world is flat. That was a fact at one time. We now know that that was wrong. So they changed it, and we have a new fact. The earth is round. So facts can change. Then a law or principle. We're going to have lots of laws and principles in science. How's that different? You can, if you got your book, and I don't care if you cheat and look it up. But what do you think? I like that. I like that. It's not just a fact, a piece of knowledge, but how that helps explain how something works. Did I sum that up okay for you? Want to add to that or think differently? Yeah.
Laws can be proven by math.
Law can be proven by math. I'll agree with that. Often there's a formula associated with a law. And you weren't here Monday, but my emphasis is equations describe nature, their relationships between different phenomena. So yes. Let's see, what did the book write? Law or principle. General hypothesis or statement about the relationship of natural quantities that has been tested over and over again and has not, I'm going to throw in, yet been contradicted. So it's like we notice some facts, and from those we make hypotheses or statements about these relationships. And we've observed that over and over again, enough that we think, you know what? This seems to be a law or principle defining the way this works in our world. The law of gravity, there's a basic one. Fact, I let go of this, it's going to go down. Yay, physics is still true. I periodically do gravity checks. The law of gravity, though, there's an equation, and it defines how how its motion changes and how fast and in which direction. And that's been repeated over and over again and not been contradicted. Yes?
Even though I've heard that it's supposed to be a law, I've read from multiple science boards that it should still be considered a theory technically. I'm not saying, but it is saying that it should be taken.
He's read that it's a law of gravity, I just mentioned, but maybe it should be taken as a theory, which is great. Let's leave, because that's my next term. Was it? Yep. What's a scientific theory? Let's try to define it first. Because we got facts, we got law or principle, and then we have something called a theory. An explanation that can lead to a fact. Good. Want to add to that? Yep. Not fully sufficiently proved. Okay. Hasn't been proven wrong, like laws and principles yet. Again, I was one of those that in your shoes, and still am when I'm in a class, I disliked when the teacher doesn't give you time to think and asks a question, especially the ones, they're turned around on the board. So, what do you guys think will be the answer to this? And then they've already written it, but you can't see it because they're still standing in front of it. They're annoying me. So I'm giving you plenty of time to answer, and it's because I hope you do answer. Or at least you're sitting there thinking about it. Commit, even if it's personal. Scientific theory, synthesis of a large body of information that encompasses well-tested and verified hypotheses about aspects of the natural world. In my mind, then, a fact is like about one thing. A law or principle is a little higher, a bit more encompassing, defining those relationships, the things we observe. And a theory is even bigger, a synthesis of large body of information that encompasses well-tested and verified hypotheses. It might include laws and principles helping to explain it also as a subset about aspects of the natural world. And this one's most often misinterpreted in science compared to the normal world. Theory to us as people is, well, that's what you think's going to happen. It may or may not be true. You agree with that? Somebody nod. Come on. Help me out. Yeah. Yes?
It takes into consideration previous facts, and it's an organized system.
It does take into consideration, previous facts. It brings all these facts and laws and principles in that have been tested over and over again to explain it overarching. And before I get too far away from it, a scientific theory, though, isn't treated as, oh, it may or may not be true. To science, that's like law, fact, governed, eternal truth. It does not mean that the theory cannot be revised. All of these can be revised if we gain more information, do more experiments, and we learn something different. Then yes, we revise these. But until then, they are our best explanation that seems to always work. When I'm dropping something and it falls, that always accurately describes it. So we're going with that until we got something better. That's how I like to think of these things. In the back.
Oh yeah, I was going to say I often think of music theory because it's
So you're saying, like, relating to music theory, they're like guidelines to help you understand and put some structure to it. That's all science really does. It's trying to help us understand and learn more about nature and how things work, specifically physics. It's the basic fundamental science. And so we build these scaffoldings, these theories that get us where we want to go until or unless we learn otherwise. And so in this semester, I'm going to expose you to many facts, laws, and theories. That does not mean that, you know, when you're older or your children, we might have learned something new. I'm sure you've heard of quantum mechanics. That was a new theory and way to describe things. And it works, so far, it works great for describing the quantum mechanical microscopic world. It works. Another good example is Einstein's special theory of relativity. You've heard of it? I'm not asking if you know what it is, but Einstein's theory of relativity works awesomely. There is a breakdown. It's based on an assumption that nothing can go faster than the speed of light, that's an ultimate speed limit. So if we ever find something that can go faster than the speed of light, does that debunk the whole theory? A lot of people think so. However, in my mind, you can still use it for speeds less than that because it still works. But if you're going faster than that, we're going to need a new theory because it just does not work and does not describe what we'll see. Example, Newton's laws. That's where we're going to start. It's the next chapter. And Newton's laws work on motion and forces at slow speeds. So when we're not going anywhere near the speed of light, these all work great and explain our world. However, if you start going near the speed of light, Newton's laws start to break down. That's when you need Einstein's theory of relativity. And so you can have theories for different sections too. You see where I'm getting at? Oh yeah, I said that. Okay. Questions? I think it's important that, if you're taking a science classes, that you realize those distinctions. Specifically, about theory versus a scientific theory. When you tell a scientist is talking about a scientific theory, they're implying, not like, oh, that's kind of a little wishy-washy, believe it or not. No, that's what works, and we don't know any better yet. But I'm willing to revise it if we have enough documentation and results to show. All right. Chapter 2. It's on Newton's first law of motion, inertia. That's what it's called. Then in Chapter 3, to understand these better, we're going to make sure you understand linear motion, what velocity, acceleration, and force really are, before we get back in Chapter 4 to Newton's second law, and Chapter 5, Newton's third law. And then we'll have a test. So I hope to get through Chapter 2 by the end of Friday, because that's what your first homework's on. I'm going to start with this one. It's probably my favorite inertia demo. I'm going to try to pull the tablecloth out from underneath the dinnerware here. You're okay. But I don't need to do it. I do it all the time. Who's ever done this? A handful of you. Usually it's more. Okay, who's always wanted to but hasn't? Okay, keep your hand up. Why didn't you do it? You're afraid you're going to break something or what?
Yes.
Who said yes?
Yeah.
Come on down. Today's the day, because if you break it, I'll just go to DI and get a new plate, okay? I'm going to give him some pointers before he does it to help teach and hopefully have a better experience. What's your name?
Scott.
Thanks, Scott, for helping. So that you guys can go home and amaze your friends too. I have 3 major suggestions and tips. 1, bunch up the tablecloth so that you're not, way back here, too much slack. Because the biggest key with this is you want to be going as fast as you can. We're going to learn that these things have mass. They're made up of substance. And a property of matter is inertia. I define it as a resistance to change. Inertia, resistance to change. Wink, wink, key, key. You should know that if you want to write it down. It's in your book. Or a sluggishness. So the faster you, when we pull on it, it's going to try to move, right? See, it moves. I changed its motion. It was at rest. You're going to try to move it. If you can do it quickly enough, its resistance might keep it put. So we want to go fast. So step number 1, go as fast as you can. Right. Within, under control. Under control, gotcha. To help you with that, a lot of people will start like this. I suggest put a little slack and start here. Then when you pull, by the time it gets taut, that's when it starts acting on it. You're already going faster. Right here you start at velocity 0. At this point you got some velocity that's greater than 0. So you're already going faster by the time it hits it. Tip number 1. Tip number 2.
Wasn't tip number 1 bunch?
Well, the bunch which allows you to get, the bunching allows you to get faster.
Okay.
To go fast. Tip number 2, well, you can name them, number them however you like. Right. Pull down. A lot of people get excited and rev up. Oh yeah, I'm going fast. That's going to apply a vertical force, which will raise them up. Not good. If you go down, then it'll just come smoothly out from underneath it. Tip number 3, learn the hard way. Cut the seam off. If you're using a tablecloth with a seam, get rid of it. Because when it tries to slide underneath, it's going to knock them up. And you don't want that. So, I'm ready when you are.
Alrighty.
So bunch her up. Let us know when you're ready.
Is that bunched?
That's good. You'll start up here. You'll go down. Wait, we'll help you out.
Right.
Hey! Thank you.
My bucket list now has one less thing on it.
See, now those of you that were afraid or intimidated, go try it. If you like, start with something non-breakable. It's fine. A lot of people get worried about this. Oh no, we'll spill it and it'll stain. Well, observations. You're a good scientist. What'd you observe? Huh? It works. Yes, we have results. We're analyzing now too. What else did you observe? Objects at rest tend to stay at rest. That is part of Newton's first law. Objects at rest. They're at rest. They're happy. So they have this property called inertia. They want to resist any change. They want to stay at rest. And if you try to change it, they're going to resist you. Good. What else?
The spoon and fork moved more than that.
Thank you. Yeah, these moved more. Why? They have less mass, which means they have less inertia. Inertia is a property of matter, and the more mass you have, this and this, actually help this work better. It means they have more inertia, more resistance to that change, and so they stay put better. These flopped around a little because they had less inertia. So thank you for bringing it up. The second half of Newton's first law.
One of the things I envisioned, especially as I was watching him pull the fabric, is like I noticed that the plate bounced a little bit because it has to move. So, I mean, as the fabric was moving out, there was just a little bit of, there was resistance, but at one point, the force of the tablecloth caused the plate to rise. It's probably something that we can't see, but that's just something that came to my mind as I was watching. But the force must have been great enough to at least break that inertia.
Good comment and observation, Brian. The tablecloth has a certain thickness, and ideally it could stay flat and slide out right from underneath the plate. In reality, as much as we try, we usually don't keep it smooth and flat and pull up a little bit. And yes, this might have lifted a little. It wants to resist change of motion in any direction. This way, friction between this and the plate, we're trying to move it this way. Any upward force was trying to make it move this way. So we did not succeed in making it stay perfectly still, but its inertia kept it pretty much in place, and at least more than these that have less inertia. So it still proves our point, but you are absolutely correct. This would be a good time to try this one. Do it over here. It's a ball and a card. And if I put the card on here, the ball over the cup, same idea. If I can move the card fast enough, the friction between it and the ball will try to get the ball to move. But the ball has mass and thus inertia, and hopefully it can stay put. And this one I think is a little cleaner. I'm sure it might lift it up a little, but the card just kind of just whoosh, right out from underneath it. Then what takes over? The ball doesn't stay completely put. Either does the plate for that much height, because now there's a force acting on it, trying to accelerate it downward. And at first it starts moving slowly. You know this too. Here's a ball. When you first let go of something, it doesn't move very fast. But watch how fast it's going by the time it gets down there. You know it's going faster. So initially it's trying to resist that motion. Second half of Newton's first law. Things in motion want to stay in motion. They have inertia also. Unless something tries to act on them to change that. So things at rest, that's a state of motion. It just happens to be zero velocity. It's not moving. So it will resist that. Once something's moving, though, it wants to stay moving. Even if nothing's acting on it. That's the clincher part. If something's moving at a constant velocity, 10 miles an hour, it will not change. It will never slow down. It won't speed up if nothing acts on it. So if you take a tennis ball, that's on my bucket list, out in space and just chuck it, whoosh, it'll just keep going at a constant speed until something interacts with it. Yeah? Can I conclude that Newton's laws are not applicable in space? They are, actually, because it works here and there. This law works everywhere that we've noticed so far. Objects at rest want to stay at rest, and objects in motion want to remain in motion at that constant speed, unless an external net force, well, technical terms, something acts on it. What we're used to, though, in this world is there's always something acting on it. Gravity. It's hard to get rid of down here. And so we always see things fall to ground, right? Remove gravity or get far enough away from the Earth and the influence is small and negligible and the thing will just keep going. What's the other big one? How about this? If I slide, wait, it slowed down. Does that violate Newton's first law? Because, I heard it, friction. Yes. There is a force between the table and that acting on it to change its motion, to slow it down. So Newton's laws still work everywhere. Yes? Friction would be in the opposite direction, yeah. If this is trying to move that way, the friction from the table acting back on it is in that direction, yes. All right, I'm going to, the last 5 minutes now, today is National Static Electricity Day. And it has nothing to do with what we're doing, but I brought an experiment to do it. But before I do it, let's see if you guys' clickers are working real fast. Oh, you know what? I think I just heard that thing shut off. Well, that's all right. We don't need that. So if you've gotten your clicker or responseware, we can try it out here real fast. All right, I got a session ID number, 361814. 361, I'm bad at remembering numbers. See, you're good. 814. If you're doing responseware, your mobile device, that's the session ID number you log in with. And I'm using for your clicker channel 44. And it doesn't matter what the question is. I open polling. You can't see it, I know. Go. I'm getting responses. If you have your clicker, when you hit it, you should see a ... smiley face. Doesn't matter what you hit. Your iClicker, it hits something. You registered it, correct? Yeah. Tell me your name. Alyssa. Alyssa? Yeah. Alyssa what? Wynn. Alyssa Wynn. Alyssa Wynn. I'm just getting it in my head because I can check to see if it I registered. It's not. I'm sorry. And responseware. You can be trying that out. Also, it should be working after you logged in with that session ID number. I've gotten 29 responses. Raise your hand if you have a device. It looks about like 29, so the rest of you haven't tried. Okay. Anybody's that didn't look like it worked other than what we've heard? 31, a couple more. Okay, we're getting there. All right, I need a volunteer for this last demonstration. It'll be more dramatic, sorry, just for visual effect, if it's somebody with longer, clean hair. Any takers? Because you might have seen some of these. It's a Van de Graaff generator, and we're going to charge somebody up. Would you like to try? You're willing? Come on down. Thanks. Just so it'll look cooler to us when your hair's all standing up. This is called a Van de Graaff generator. It's after a guy's last name. And we're not studying electricity and magnetism this semester, but I'll give you your brief rundown. If you stand up here, I'm insulating her from the floor so she's not a direct contact. And I'm keeping her away from the table so she doesn't arc to it. Can you reach that with your right hand? Mm-hmm. It's safe. Yeah. Yeah, like that. You want good contact. There you go. All right, you're safe. Don't let go. Okay. Don't stretch and try to reach anything. Then it might spark. Okay. It'll hurt a little, but it won't kill you. Don't worry. All right, I'm going to turn it on. Don't let go. And it'll take a moment. The way this works is the power just runs a motor in the bottom, and all that motor does is that belt you see turning. Every time it comes off the roller, you're separating two materials. And you can take charge with it. One type of material will like electrons more than the other. It's like rubbing a balloon on your hair. When you do that, you're just separating charges, positives and negatives, electrons and protons. So what we're doing right now is separating them, and they're building up on the dome. She's touching the dome so they can travel onto her body. And we can see it in her hair. Like charges, let's say for argument's sake, all the negative charges are moving onto her. They don't like each other, so they want to get away from each other. They repel. Best way to do that is up on her hair. Make it stand up and spread apart. Can you give us one of these? Now, of course, National Static Electricity Day, and I looked in the weather, and it's 100% humidity today, which means a lot of the charge leaks off into the water, but oh well, we're trying. You can see it standing up a bit though, can't you? Can you see yourself? Yeah. It's standing up in the back too, do you mind? It'll go back down. There we go. So, you can try this at home. If you take Scotch tape and you pull it off the roll, you separated it. It's charged. And make it about that long. Your finger, it'll attract to it. Pull a second piece off, and you got two pieces. They should be charged the same way, and if you bring them near each other, they should repel, and you can see it. But this is a Van de Graaff generator. Thank you. Don't let go yet. Happy Static Electricity Day, and I'll see you Friday. Now you can let go. Thank you very much.